This is me doing a continuity test on the metal wire, and it was beeping, so it did have continuity. It makes sense because it's a metal hollow. It's essentially a hollow wire. Um, then come over here to do a continuity test on the handle of the drawer. It's not beeping because it's not real metal. It's fake. It's just painted to look like metal. And then I tested the multimeter, and it worked. Now I am testing the iPhone charger. See, it's reading 5 volts. The power supply, as you'll see in a second, shows 5 volts. And I'm going to bring it back up to 5 volts again. And then it's on DC specifically because it's a direct current. The power supply transfers from AC to DC. And see, USB-A, which is how I connected the iPhone charger to this power supply. USB-A output 5 volts. Made in Vietnam. Then we have the wall outlet. Gotta plug the ground in. I had to make sure it was in contact with the metal. Then I plugged the live in, the hot one in, make sure it was in contact, and then it's in AC. I believe the multimeter is only taking the average. It's not showing me the continuous changing alternating current because the voltage is not changing at all, even though it should be. So I believe it's just showing me the average, but the average is 121.1, and then it varies slightly. Or maybe it is alternating. Then there's the car battery. This is while it's off. Most car batteries are 12 volts, direct current specifically. So see, I have it set to 20, direct current voltage, and it's reading 12.63 volts, a little higher than 12. Doesn't really mean anything. And then if we do it while it's on, while the car's on, it's going to read higher. Still direct current, 14.15 volts. That's because the alternator is now charging the battery while the battery is still in use. So the voltage is now 14 volts instead of 12 volts because the battery is not the only power supply now. The alternator is also giving power. And that's why the voltage is higher. That's the end. All right.